let's get into today's lesson. I hope everybody's ready. We are going to be doing a quick proof of quadrilaterals, right? And this is a proof that we've already done before. So we are going to talk about how we need to prove something. It says here we are given that AE is a median, right, of triangle ABD, right? And E is the midpoint of AC. So AE is a median of that triangle. And point E is the midpoint of EC. Now, we know that there's another word for the word midpoint. Who can remember? We've been talking about it quite often, especially in this particular example. Who can remember what the other word for midpoint that we're looking for? We learned about it. It's something that cuts other things in half. Not a midpoint, a what? No, I didn't quite get that. No. It starts with a B. I'll remind you guys, it starts with a B. Almost, Desmarine. Yes, two lines can intersect. Tsejo, there it is. That's the one. It's the word bisect. And I don't know who unmuted and said something, but if you said bisect, I'm realizing now you could have said bisect and I just didn't hear it. Good. A bisector. Okay, that's the one we're looking for. So a bisector is basically another line or a point that cuts the other two sides in half, right? It cuts them in half, which tells me that BE is equal to what? What would BE be equal to?
Ma'am, wanted to be equal to ED.
It is, absolutely. Because it's been cut in half, obviously it's been cut in two equal parts, which means B is equal to ED. And we're told here that E is the midpoint of AC, which means that AE, hello, Bicanyo, AE is also the midpoint or is also equal to EC, right? Now, the question here says, we need to prove that ABCD is a parallelogram. All right, and there are about 3 ways that we can prove that something is a parallelogram. Does anybody remember these 3 ways? Okay, I'll remind us, first one is opposite sides are what? Opposite sides, something.
Equal.
Yes, I mean, so absolutely, they're equal. Yes, that's it. Opposite sides equal. And then the other one also starts with opposite. Who remembers? Opposite what?
Angles.
Opposite angles. Good. Opposite angles are equal. And then there's one, the very last one, the one that we're actually going to use today. Who remembers? Okay, I'll give us a quick reminder because I think, no, Saneli. So unfortunately, if we prove that the two sets of these are parallel, that would only help us in proving that the opposite angles are equal. Okay, so the parallel part of it, yeah. I mean, we could say that, but if we can see that the opposite angles are equal, then we already know it's a parallelogram, so we don't have to go that far. The other one is that the diagonals must what? Diagonals something, and it's the word we've just figured out.
Bisect each other.
They bisect, correct. Good, they bisect each other. Nice ones, yeah. Good. So today we're going to be using this very reason, the fact that the diagonals bisect. Okay, so let's start our proof properly. Okay, by the way, we've been told that E is the midpoint of ABD, and that AE or E is a midpoint of AC. All right, so we're going to say we are required to prove. Okay, now if we think about the information they've given us, what we're then going to have to prove here is that AE is equal to EC. And what else would I have to prove in order for this to work? AE is equal to EC, so that one is equal to that one. And which other two also need to be equal? Correct, Seho. Yo, on the money. Good. BE needs to E. ED. Is that where we were going with this? Yes. You got it. That's correct. Good, Seho. Excellent work. All right, so those are the two things that we're going to prove. Now, we need to start our actual proof. So we're going to go prove. And because we're proving sides, we're proving that sides are equal. Are we going to prove congruence or similarity? What are we proving? We're proving that sides are equal to each other. So it's either going to be congruence or similarity. Which one is it? Which one of the two uses sides as a proof? Correct, Wiganyo, absolutely. It is congruence because we need to prove that sides are equal to each other. Right? Not sides in proportion. Sides are equal. So that tells us that we need to now look at congruence. All right. So we're going to then prove we need to find two triangles that we're going to work with, because in order to prove congruence, we're going to use triangles. So we need to say proof in triangle. Which triangle would we use? Okay, I'll tell you something. It's not going to help us to use the really big triangles, because if we try to use the really big triangles, we're going to end up having to prove this side, and we don't know anything about that side. And we're going to have to end up trying to prove this side, and we don't know anything about that side. So instead of using the big triangles, which triangles can we use? Can we map them out? Okay, let's think about this. I know that I need to prove BE in one of the triangles, and I need to prove AE in one of the other triangles. So are we seeing the triangle that ma'am would have to use here? Are we seeing it? Yes, absolutely, Saneli. So we can say in triangle ABE and triangle. Now check where we started. We started on a sharp corner and we went up past the short side and then down the middle. So when we start, we're going to start at C and go where in the next triangle? From C to but if we went to E, if we went from C to E, do you see how we go straight down the middle? We can't go down the middle because in the other triangle, we went from A past the short side first. So if I start at C, I'd need to go past the short side. That's it, Desmarie. Absolutely good. So triangle ABE and triangle CDE. All right, and because we're proving congruence, then we need to prove three things. 1, 2, 3. All right, I'm going to map those triangles out one more time, and let's see what it is that we need to prove here. Okay, there we go. A, B, E, C, C, D, E. I'm lying. It's absolutely C, D, E. Oh, now even teacher Coco's lying. C, D, E. All right, let's look at these two triangles and let's think of 3 reasons as to why each of these are equal to each other. Okay, I'm going to start us off. I'm going to say that AE is equal to EC. Okay, and I want you guys to find me the reason. I'm going to move over to the side so you can see the information they've given us, because they never give us information for free. Okay, they've given us all of this lovely information. So if ma'am says AE is equal to EC, where did ma'am get this idea? By the way, the AC is actually down here. E is the midpoint of AC. And I think I've just given away the answer. Why can ma'am say that AE is equal to EC? Anyone? Okay. It's given. It's given, Seho. It is. Okay, let's go back. They've given us this information. They've told us that E is the midpoint of AC. Okay, it's not because they bisect. Okay, because for them to bisect suddenly, so I would need to know that both of them go this way. So at the moment, I can't say that. That's what I'm trying to prove. Okay, I can say we are given E is midpoint. That's what we've been given. They've told us this, that E is the midpoint, right? What else do we know? I can also say that BE is equal to ED. And again, the information is going to come from here. Why can I say that? Okay, again, it's been given to us. We're told here that AE is the median to triangle ABD. Okay, not in this case, AE. We need to be very specific, Tsepo. We need to say AE is the median. Okay, we are given that AE is the median. Okay, now I need exactly one more reason. Bonus points to whoever can find it. And it's quite easy. I'll tell you what, it's not a side. I'll give you a hint. It's not a side. This is a side and this is a side. Let's look for the last one. Bonus points for who can find it. Okay, I guess. Yes!
angle.
I give myself bonus points, but Saneli so absolutely nailed it on the head there. We can name this E1 and we can name that E2. And then we can say that E1 is equal to E2 because of vert-op angles. Angle E1 is equal to angle E2, and our reason is because of vert-op angles. Well done. Nice job. Very nicely done. All right. Then we've got our three reasons. Now we can say, therefore, triangle ABE is congruent to triangle CDE. What is our reason? It's definitely not side-side angle, because remember, side-side angle is one of those that doesn't exist. So who can find me the actual reason here? Oh, excuse me. Correct, Kat. It's a side, an included angle, and a side. Yes. So we've got a side, an angle, and a side. You see how the angle is in between the two of them? So this is actually side, angle, side. Well done, Kat. Lovely. All right. And now, because we know that these two are equal to each other and that they are that they bisect, or that there's a bisector for these two, then we can say, therefore, ABCD is a parallelogram, it's a palm. Okay, and our reason for that will be because diagonals bisect. Okay, and I know it sounds like we're going in a roundabout way. It normally is. That's how we kind of do it. All right, give me a thumbs up. Is everybody okay with this? I know it's really difficult. Sometimes, especially if ma'am isn't here, some of you would have been like, yo, where do I even, ma'am, hi? I know, but it definitely takes practice. And especially Euclidean geometry, if you can't see things, then you're going to have to practice them in order to see them easier. Okay, I'm going to tell you guys, I wasn't the best at geometry myself in school, so it took me a while to get used to it as well. Thumbs up for now. All right, let's not hop on quadrilaterals that much anymore because we've done our parallelograms and the such and the such. Today, we're going to be focusing on the midpoint theorem. Just give me a thumbs up if you've done the midpoint theorem at school, thumbs down if you have not, please. My enemy. Okay, Karatulu says no. Okay, so just one person hasn't seen it. Okay, but that's fine. We're going to take it a bit slow just so we understand exactly what it is that we're doing. Okay. Okay. All right. So let's start with what the actual theorem says, because we're going to have to use the theorem as we go along. Okay. So oh, it's about analytical. Oh my goodness. Okay. Desmarie, my only suggestion would be for you to go watch the videos that I did last year. Okay. On analytical geometry, because unfortunately, I don't think we'll get to it in time. I'm so sorry. We only start analytical geometry next week. So on Monday, which is kind of nasty, but okay. So I would say go to YouTube and watch last year's grade 10 videos on analytical geometry. Okay. I'm happy to help if you have a question or two as well. All right, let's talk about the midpoint theorem. Now, I've written down the official definition of the midpoint theorem here, but we're going to break it down because nobody's going to ask you to use this much English in maths, and that's not the point. Okay, so what the midpoint theorem actually says is the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of the length of the third side. So what this actually means is if I have a triangle ABC and I go to side AB, if I go to side AB and I find the midpoint of side AB, and then I go to side AC and I find the midpoint of that side. If I join these two with a straight line, then that tells me that side DE or the line DE is parallel to line BC and that DE is half the size of BC. Okay, so DE equals half of BC, and BC will then equal 2 times DE. Okay, so if they give us that these two things are equal to each other, then we can automatically assume that these two lines are parallel and that half of, or this is half the size of that. Okay, now we don't only just use this the way that Mem has described, we are also going to learn of something called the converse. Has anybody heard of the converse? Who can tell me, what does the converse mean? And I'm not talking about shoes. I'll tell you guys that much. I'm not talking about All Stars. Just now, somebody's going to tell me Chuck Taylor's. No, we're not talking about Correct. Yes, that's it. The converse, thank you, Kat, for staying on topic, unlike Desmarie, who's busy laughing at my lame jokes. Okay. So the converse means basically the opposite of the midpoint theorem. But we can't call it the opposite because they actually work hand in hand. All right. So this is what this actually means. It means if we are given a triangle ABC, and they tell us in this triangle that DE is parallel to BC, and that DE is half the size of BC, then we can assume that D is a midpoint and therefore cuts this into two equal parts, and that E is a midpoint that cuts this into two equal parts. So I want us to note this. It's very, very important that we use it in the correct order. All right. If they give us the sides, if they tell us that sides are equal, then we use the midpoint theorem. That's our reason. Mid-PT-THM, midpoint theorem. But if they tell us that the two lines are parallel, or if they tell us that half of DE is equal to BC, then over here, we cannot use the midpoint theorem. We need to use the converse of the midpoint theorem. Okay, converse mid-PT. Okay, give me a thumbs up if everybody sees what ma'am is saying here. Are we seeing the difference between the two? We use the midpoint theorem if they've given us that the sides are equal. But if they give us the fact that the sides are parallel or that one is half of the other, then we use converse as our reason. All right, is everybody with me? Are we all good? Can we put this into practice? And I've got some really sticky examples today. Okay, I'm going to show you the example, and then I'm going to blow my nose. I want you guys to think about it for a second while I blow my nose. Okay, have a look at this.
It looks mind-blowing.
I'm hearing a voice somewhere. Okay, I'm guessing they muted. All right. Okay, are we ready with an answer? Can we see exactly what it is that we need to use here? Okay, let's go ahead and look at what they've given us here. Okay. Just give me oh, guys, hey, I'm shaking. Correct. Okay, good. Saneliso says the external angles, correct, is something to keep in mind. Absolutely. Right. Okay, so this question isn't actually about midpoint, but that's fine. All right, so we need to calculate for the for the angles in this particular triangle. All right, so how can we go about answering this question? What are we thinking? Where would we start? I see here they've told me in triangle AEB, AB is parallel to DF. And when we hear the word parallel, what should we be thinking? Parallel lines? Fun angles. Yes, absolutely. Fun. We should be thinking fun. So let's look for that F or that U or that N. What are we seeing, guys?
Z is equals to 80 degrees.
Correct. Z
Corresponding
is
angle.
80 degrees. That's it. Correct. For the F, because of the F. Good. We can start by saying
Yeah.
Z is equal to 80 degrees. Good. Corresponding angles, you're not,
AB,
you still need to say?
AB to DF.
Correct. Good. AB is parallel to DF. Well done. Excellent, good, good, excellent work. There we go. I've got it. All right, so we've got Z. We know that Z is 80 degrees. What else can we figure out, guys? Okay, Saneliso's actually mentioned, was it Tsecho? It's Saneliso. You've actually mentioned it, Saneliso, and that's actually going to help us here. I know I can work out that and that at the same time. Who can tell me how?
Is it angles on a straight line?
No, not quite. But Saneliso did say something about the exterior angles. Do we remember anything about the exterior angles? That's it. Correct. Saneliso says 4x plus 80 degrees is equal to 8x. And what's this reason? Who remembers? It's the external angle of a triangle is equal to the opposite interior angles. Opposite interior angles. And guys, this is grade 8. We must know this. It's from grade 8. Okay, and now we can solve for x. I'm going to give you guys 1 minute to solve for x for me, please. Tell me what x is equal to. Thank you, Sally. Beautiful. All right, I know that I'm going to take 8x over to the other side, and then I'm going to bring 80 over to the other side. So I'm going to end up with 4x minus 8x is equal to negative 80 degrees. 4x minus 8x will give us negative 4x is equal to negative 80. And then we're going to just divide by negative 4 on both sides, negative 4. Right, and that gives me that x is equal to 20 degrees. Okay, lovely. So now we've got x is equal to 20, which tells me that this is also 80 degrees. And 8 times 20, this would give us 160 degrees. All right, and now we can work out what y is. Yes? How much is y equal to, guys? Y is equal to 20. Yes, good. Y is equal to 20 degrees. Okay, you can use 2 reasons for this one. One of them is what Sia said. We can use angles on a straight line. Or you could also use the interior angles of a triangle. Okay, you can use any of those. Okay. All right, so this was more just about fun angles and parallel lines. Let's look at what we've been given in the next one. Okay, this one is a little bit more tricky, right? Because they've given us a lot more information than what we were hoping for. So they say here, not what we were hoping for, than what we had before. Consider the diagram below and calculate the unknowns x, y, and z. All right, giving reasons for your answers. All right, let's start with the easiest ones, right? But I want us to note here that they've given us that and that. What does that tell me? And they've also told me this and this. Okay, before we can start with the proof, what can we deduce from that, from seeing that? Okay, I'm going to write it down. AD is equal to DB, and AE is equal to EC.
Is it the midpoint theorem?
It is the midpoint theorem. Absolutely, it is. Right. We said that if we are given that this side is equal to that side, and that this side is equal to this side, then, therefore, we can conclude that DE is what? DE is?
Parallel to BC.
Beautiful. Is parallel to BC. And our reason is going to be midpoint theorem, mid-PT theorem. Okay, it's not the converse this time because they've given us the sides. Right. What else can we conclude?
We can conclude that DE is half the length of BC.
That's it, is half BC. And again, that is also the midpoint theorem. Okay, well done. Nicely done. Okay, now we can already tell just by looking at that, that we know that DE is parallel to BC, right? Then we know we can work on X and Y and Z using the midpoint theorem. So let's go. Therefore, X is equal to how much? How much is X equal to? Yes, Kanyo, absolutely. It's equal to 50 degrees. And I want us to note, do you see how ma'am is not going through all the motions, right? Normally we would do this. We would go X plus 70 plus 60 degrees is equal to 180 degrees, right? That's it, Kanyo, beautiful. Right, and then we'd say interior angles of a triangle. Right, and then from here, I can automatically just say, therefore, X is equal to 50 degrees. Okay, so it's not necessary for us in grade 10 to have to write it out like you're still learning about equations from grade 8. No, we can go straight from the statement to the answer. Okay, I beg to say that I would give you the mark if you could just give us that. I know that at my school, they would allow you to just say X is equal to 50 and keep it moving, as long as there's a reason here. If you just said interior angles of a triangle. All right, excuse me one more time. Oh, guys, blue is going to be the death of me. All right, then as Kanyo says, y is equal to 50 degrees because of corresponding angles, but you've only given me half a job here, Kanyo. What are you missing?
BC is parallel to DE.
That's it. BC is parallel to DE. And guys, I'm very, very serious. They will not give you the mark if you do not put in the parallel lines. Okay. If you just say corresponding angles, they're not going to give it to you. You must state the parallel lines. All right. Okay. And then that tells me that therefore Z is equal to how much? What is Z equal to here? Good, Sally, 4 centimeters, right? And that again is because of our midpoint theorem. Midpoint theorem. All right. How are we feeling? Good, bad, meh? How does midpoint theorem feel? I bet you it's much easier than proving quadrilaterals. I can tell you that much. How are we doing? Yeah, we're all good? Excellent. All right, let's get on with the next part. Right, here is our next question. Okay, there's a lot of information and there's a lot of things we're going to have to prove before we get to the answer for this. So I just want to delete all of that. We don't need that today. Okay, so it says here, in the sketch, DE is parallel to FG and FG is parallel to BC. So just from hearing this information, okay, just from hearing this information, we know that that is parallel to that, and that is parallel to that. So all three of them are parallel to each other. And then they say to us that AD is equal to DF. So AD is equal to DF, right? So we know that that is equal to that. And AF, that whole part, AF is equal to FB. So those two are equal to each other. So that is equal to that. All right. Then they tell us that BC, the length of BC is 160 millimeters. 160 millimeters. Okay. And the question comes down here. Calculate the length of DE. All right. And it's easy for us. I know somebody's just going to be like, oh, duh, ma'am, half of 160. Therefore, it's no. We need to go through the legwork and let's explain how we get to the idea that this is actually, that DE is actually equal to what it is. All right, who can give us an idea? Where will we start? Okay, just by looking at this, where they tell us this part, where each of them are parallel to each other, right? What does that tell us about the theorem that we're going to use? Are we going to use the midpoint or are we going to use the converse? Oh, that's it. Correct, Sally. We have to use the converse because they've given us the converse information. Just give me 1 second. Okay, can I just get a consensus from everyone? Can I give you guys a few minutes to try and find the answer on your own, and we'll compare notes because I know we'll be able to find them, the reasons, while ma'am goes to fix her nose, because otherwise I'm going to be talking like I'm underwater for the next 30 minutes. Okay, yes, thumbs up. Can I give you guys a chance to do this on your own? Ooh, all right. Okay, if Saneliso says yes, then everybody's outvoted. Everyone else is outvoted. All right, I'm going to give you guys 5 minutes. I'm just quickly going to go fix my nose. All right, pop your favorite emoji in the chat when you're ready. All right, peeps, let's not stress. Okay, let's see if ma'am can help. All right, so Sally has been nice enough to let us know that we're going to use the converse to start off. Right, so let's start with what we know is obvious. Right, we've been told that BC is parallel to FC, right? I mean to FG, right? So we can automatically then say that half of FG is equal to what? What is half of FG equal to?
To DE. Oh, to BC. Yeah.
BC, yes, to BC. Right. Half of FG is equal to BC. And who can tell me what's the reason? Why can we say that? Remember, we're using the fact that these two are parallel and that they've given us those, that those are equal. So our reason would have to be converse.
Oh.
Converse midpoint theorem. Do you see? Because we use the fact that the parallel lines are there, we are doing the inverse of the theorem. Mid-PT theorem. Right. In fact, we could have started by saying in triangle ABC, because we're using the big triangle at the moment. And then later on, when we have the answer for FG, then we can use the smaller triangle to find DE. So I know that half of FG is equal to, we've been told that BC is equal to 160 millimeters. Right? Or have I done it the wrong way around? Yes, guys, I've done it the wrong way around. I'm sorry. Half of BC is equal to FG. Sorry. Half of BC is equal to FG. My apologies, guys. Otherwise, the answer was going to come out 320 and it wouldn't make any sense. Half of 160 is equal to FG. Therefore, FG is equal to how much? To 80 millimeters. 80 millimeters, and it's such a simple question. Right, so this part we know is now equal to 80 millimeters. Now, look at the information they've given us again. They've told us that DE is parallel to FG, and they've given us one side of equal, or one pair of equal sides, right? So we can then say that half of FG is equal to what? Is equal to we need to start. That's it, Sally. That's it, Sally. Remember, guys, we need to start with the reason first, the statement and the reason. Then we can say that FG is equal to 40. Okay, DE. So we have to say half of FG is equal to DE. And what is my reason? I'm using the parallel lines, guys. Therefore, I must use the converse. I'm going to use the converse of the midpoint theorem. Okay. Then I can say half of 80 is equal to DE. Therefore, DE is equal to 40. And you guys, you're not wrong. We just need to lay it out properly so we have a statement and a reason. Okay, so Desmarie and Palisa, you're not wrong. Not at all. Okay, it's just the way that we set it out makes it look like we actually understand what it is that we're saying. Do you see, Buikanyo? This is quite simple, hey? It's not that bad. Hey, Sia? I think we were just overthinking it. We were overthinking it. All right, shall we try another one? Oh my goodness, my doggies are yapping all over again. All right, let's look at this one over here. And this one is a big one. It's a doozy. Let me see maybe if this one is, oh, that one isn't any better. Let's start here. Okay, look at this. Okay. It says the diagram below is not drawn to scale, which doesn't really matter. It doesn't give us much. Okay. Look at the information they've given us. They've given us that QS is parallel to TV. They've given us that PQ is parallel to ST. So before we even start our answer, are we going to use the midpoint theorem or are we going to use the converse of the midpoint theorem? Correct, Kat. It is. Because they haven't given us all the sides equal to each other and they've given us parallel lines, that automatically means we need to use the converse. If they give us parallel lines and one of the sides, then we need to use the converse. Now, I want us to be very careful. Over here, they're telling us that QS is parallel to TV. Just 1 second, guys. All right, they're saying that QS is parallel to TV. So I need us to be very careful in that we can tell from looking at this that we're working in two different triangles. Can we see it? There is the triangle with QS. Do we see it? That's the triangle with QS and TV. And then they're also saying PQ is parallel to ST, and the PQ and parallel to ST is that big triangle, that one. Okay, so we're actually working in two different triangles here. Okay, so the question here says, okay, QT is equal to TR, and they've both told us that both of them are 9 centimeters, and PS is equal to 15 centimeters. Okay, question 1 says, prove that VR is equal to 7.5 centimeters. Okay, now we have to note that VR is part of the small circle, right? But SR is part of the big circle. Why am I calling them circles? Triangles. Sorry, I meant triangles, right? So we need to find a way to get from the big triangle to the small triangle. Now, they've given us parallel lines, right? They've told us, let's start with the big triangle. I'm going to say in triangle, big triangle would be P, Q, R, right? I can say that PS is equal to SR, which is equal to 15 centimeters. Somebody tell me why. Why can ma'am say that? Okay, let's go have a look at it again. Shall we look at it again? Okay, I'm working in the big triangle, the big one, right? If we look at the big triangle, which side is PQ parallel to? PQ is parallel to which side? To ST, correct. PQ is parallel to ST. Now, when they've given me parallel lines, am I using the midpoint theorem or the converse midpoint theorem? Midpoint or converse? Correct. I'm using the converse because they haven't told me that all my sides are equal, therefore. Right. All right. So that tells me that if I'm using that tells me that if this side is cut in half, and that is equal to this side, right? If that's the part that cuts it in half, that means PS must be equal to, where has it been cut in half? PS must equal SR. Is everybody seeing where it's coming from? Remember, guys, they've just said this diagram is not drawn to scale. Okay, so I know it's probably because you're like, hi, man, how is that 15 and this also 15 when that is small and that is big? It's because it hasn't been drawn to scale. Okay, that's the only reason why. It has nothing to do with the actual question itself. It just hasn't been drawn to scale. All right, and our reason here is going to be the converse of the midpoint theorem, converse mid-PT theorem. Okay, so now we know that SR is equal to 15 centimeters. Right, now, how does that connect us then to the smaller triangle? If we know that the distance from here to here, what is the next triangle I'm going to use? I'm going to then say in triangle what? In triangle, let's look at the small one. Yes, that's it. Correct. In RSQ. You're spot on, Wikanyo. In RSQ. that one there, right? So in triangle RSQ, right, what can we conclude from looking at this? We've been given parallel lines, and we've been told that this side is cut in half, and that side is cut in half, and we know that the distance from S to R is 15, right? I can then say SV is equal to VR, which is equal to how much? By the way, I'm saying that this part SV is equal to VR, and they're both equal to how much? 7.5. Correct. 7.5 centimeters. And our reason here is also going to be the converse of the midpoint theorem. All right. How are we feeling about this? Are we all okay with how to get to these answers? Yes, is everybody seeing what ma'am is doing here? Okay, cool. All right. Now it says, question two says, calculate PQ if PQ is 16/5 of VR. We know what VR is, right? VR is 7.5. So PQ is equal to 16/5 times 7.5. Seven and a half. Somebody punch out a calculator, give us an answer. Oh, something over 10. What are we going to get, folks? What is the length of PQ? Anybody? Anybody got an answer for me? Thank you, Desmarie. We're going to get 11.2. Can you give it to me as a fraction, please, my darling? What did the calculator give you as a fraction? How much?
56/5.
56/5. Okay, thank you, lovely. All right, so we know that PQ is equal to 56/5. All right, so PQ is 56/5, which can also loosely translate to 11,2. All right. It's actually 11.1/5. Yeah, 11.1/5, right? Which doesn't really make a difference, 11.1/5. Okay, now it says hence. Hence means use the information you have just discovered to prove that PQ, do you see how that little cap is on Q? Prove that angle Q is 90 degrees. So they want us to prove that this angle over here is 90 degrees. How would we do that? We've only got sides. How would we then prove that something's equal to 90 degrees if we only have sides? Our trusted old friend, who remembers his name? Okay, I'll give you guys a hint. When do we use right-angled triangles? Nobody remembers. Am I going to give myself sweets? I'm going to give myself a sweet. Ah, there it is. Nicely done. Just in the nick of time. We're going to use Pythag. Okay, we're going to use Pythagoras. So in order for us to prove that that's a 90-degree angle, all we need to prove is that the short side squared plus the short side squared is equal to the long side squared. Now, we know that what is the distance of this whole side? How much is PR? From here to there. My drawing is not getting any better. It's 30, thank you. Good, it's 30 centimeters. Right, we know that this short side over here is going to be 18 because it's 9 and 9. Good. So we've now got 30 and 18. And now we know that we need to prove that this side squared plus that side squared is equal to 30 degrees. So let's do the work. We're going to say PQ squared plus QR squared is equal to PR squared. Okay. And we must give a reason, I think. Right. Now I know PQ squared is going to be 56 over 5 all squared plus 18 all squared. And that must give us PR all squared. Okay. So let's calculate for that. PR is going to equal to the square root of 56 over 5 all squared plus 18 all squared. Okay, punch that into a calculator. It should give us 30. We are just confirming. Okay. So just give me a yes, ma'am, if you found the answer. Let me know if it's true. $21.2. Huh. Okay, so I don't know how that works out because it's not supposed to be 21.2, 21,2. Okay, it's supposed to give us 30 centimeters, unless we've done something odd, something weird. Which I don't think we did. $106 over 5 is still going to give us something like 21. Yeah, 21 and 1/5. Okay, it doesn't give us 30. Okay, I'm going to go and find out why that is. All right, but unfortunately, we have come to the end of today's lesson. All right, so I can't actually continue. We will start with this exact sum in Wednesday's lesson. Okay. Because we are